So 0.05, 0.10, 0.15,
Yeah, you can take a
0.20,
difference of 5, 0.5,
0.20,
0.10.
0.20, and 0.25. And then acceleration 0.08, so 0.08 is right here. Then 0.18, which is right here. 0.25, which is right there. 0.32, which is right here. 0.41, which is right here. Put the results and draw a line of best fit. So show the relationship between the resultant force on the trolley and the acceleration of the trolley. As resultant increases, so does
We
acceleration.
can say proportional, right? This relation when both of them are increasing with each other or decreasing is called proportional.
Describe how the investigation could be improved to reduce the effect of random errors.
What to do to reduce random error?
Repeat.
Yes, repeat the experiment or ignore um, the points which are not matching with others. Okay.
Write down the equation which links acceleration, mass, and force. So, acceleration. Um,
Force is equals to.
1 second.
Okay.
Acceleration, mass, and resultant force. So AM and F. F equals MA.
Yes, that's correct. F equals ma. Next question.
Resultant force on trolley is 0.75 newtons. Mass of trolley 0.60. Calculate acceleration. So acceleration is equal to resultant divided by mass.
Yes.
So then so 0.375 divided by 0.60 kilograms.
Yes.
So 0.375 divided by 0.60 equals 0.575 meters per second squared.
0.625, right?
575.
Did you divide 0.375 with 0.6?
Yeah.
I think it is 625. Let me check in marking scheme.
Oh, wait. I did 345. 0.625 meters per second squared.
Yeah.
The sun is a stable star. This is because the force is pulling inward caused by
Gravity.
gravity are in equilibrium with the forces pushing outward caused by the energy released by nuclear fission.
Yeah, nuclear fusion.
Write down the equation relates distance traveled, speed, and time.
Hmm.
Yeah. Okay. Distance traveled, speed, and time. S, V, and T. Distance S, V, and T.
So speed.
Distance S equals VT.
Yeah, S equals VT. You can say that. S is distance where. Okay. Let's see next.
Calculate time taken for the light of sun to reach Earth. So time is equal to distance divided by speed.
Yes.
So 1.5 times 10 to the power of 11 divided by 3 times 10 to the power of 8. 1.5 times 10 to the power of 11 divided by 3 times 10 to the power of 8. It's 500.
Yes, 500 seconds. That's correct. Good. Let's see next question.
Some stars are much more massive than the sun. Describe the life cycle of stars much more massive. Describe the life cycle of stars much more massive than the sun, including the formation of new elements. Uh, don't know that.
Okay. So first step is nebula and protostar. So which is stars form from a cloud of dust and gas. Stars form from cloud of dust and gas, which is called nebula. Okay, and gravity pulls the gas together, which form a protostar. Okay, gravity pulls gas together, which form protostar. After this, fusion.
The gas is then pulled together by gravity
Yeah, which form protostar.
to form a protostar.
After second step, after this is fusion of hydrogen nuclei into helium. We know when hydrogen combines, they make helium, which
Yeah.
release massive amount of energy. Releases massive energy. The stars remain stable as long as inward force of gravity is balanced with outward fusion. But once hydrogen um, runs out, the stars expand and cools. Once hydrogen runs out, stars expand and cools, inside the core, helium nuclei fuse to form heavier element up to iron.
Once hydrogen what?
Runs out, stars
Yeah.
expand and cools. Helium nuclei fuse to form heavier elements up to iron. Did you write that?
Yeah.
Next step is now what about heavier elements? So next step is supernova. Why my pen is not working? Uh, Okay, write it down. Supernova, when fusion can no longer produce enough energy
When fusion can no longer provide enough energy
to counteract gravity,
to counter add
counteract gravity,
act gravity.
the stars collapses suddenly and explode in supernova.
So collapses suddenly and explodes in supernova.
Next step is the immense energy of a supernova
Immense energy, a supernova
provide the conditions
provides the conditions
necessary to fuse elements
necessary to fuse
heavier than iron.
elements heavier than iron.
Yeah. Next is the last point is the remaining core collapses into either a neutron star,
The remaining what?
remaining core collapses
Collapses
into either a neutron star, done.
yeah.
Okay, let's see next question. I think this question is repeated. We have done this question, so you should remember it, right? You should know the main sequence.
Which property of a star does the range of wavelengths depend on? Longitude.
Yeah,
What?
which is the correct option?
Is it volume?
No, temperature. It's temperature.
Should investigate the refraction of light at the boundary between air and glass. The ray of light from the ray box should be as narrow as possible. Explain why using a wider ray box will give less accurate results than using a narrow. A wider ray will give a different angle, or a less accurate angle
Yeah,
on protractor.
yes. Because difficulty locating the center, right? It is harder to judge exactly where the center of wider ray is, making it difficult to mark the precise point of angle. Also, increased uncertainty, like a wider ray leads to a large uncertainty when measuring angle with a protector, as the edge of the ray covers a range of degrees rather than a single specific point, right?
Yeah,
Let's see this.
I need to draw a line of best. Um, uh, draw a line. Do I draw a line of best fit, or
Yeah, for you need to, in this question, it is just asking estimate the angle of refraction. Okay, so yeah, draw a line, extend it, extend this line till
do I use a
80.
ruler, or
Yeah, just or even like
because it's
you
a
can just,
curve?
is it a bit curved, just connect all the points, and here you can see in this part it is straight, a bit straight, these 4 points, so it will go straight like this.
Mm.
Just
So
join all these points.
ANT is at 42.5.
Yeah, it's between 40 and 43. Okay, 42.5. Yes.
Third method that the student could have used to attain the results shown in figure 4. Um, get a glass block,
Yeah, place a glass block.
place on paper,
Yeah,
draw around it, then set up, then draw a normal
yeah,
at 90
using,
degrees using ruler. Then set up light ray box
yes,
with single exit filter.
using ray box, shine a ray out of ray out light into the block, mark where ray enters the block and exit the
Into
block,
block marking where it enters
and exits,
and exits.
then remove glass block and connect the points.
Move glass block connect points and
Then you can measure the angle of
find
incidence.
angle of incidence and angle of refraction
Yes, using a protector.
using protractor.
And now you are just going to repeat this for different angles of incidence. Okay.
Yeah.
Yeah, so now look at the graph. It's going angle of incidences from 0 to 80 degrees, right? By
Yeah.
increasing by 10 degrees. So write down that keeping a 10 degrees interval, measure different angle of, repeat for different angle of incidence of 10-degree intervals.
The student repeated each measurement 3 times. The angle of incidence was 40 degrees. The three measured values for the angle of refraction were 28, 25, and 22. Estimate the uncertainty in the angle of refraction when the angle of incidence was 40. Do 28 minus 22.
Yeah, just do 28 minus 22, divide by 2,
5,
maximum minus minimum, divide by 2.
6 divided by 2.
This is how we find uncertainty.
So 6 divided by 2 is 3.
Yeah, so it's just 3.
What property of light wave changes when it's refracted? Velocity, frequency.
It's velocity. Velocity changes.
Yeah. The door is fitted with a security lens and lock. Lens is concave. Figure 5 is an incomplete ray diagram representing a visitor standing near the security lens. Complete figure 5 to show how an image of the visitor is formed by the concave lens. Draw an arrow to represent the image.
So let me show you. So basically, this is the visitor. If the light goes straight from here parallel to this axis, this is the arrow, so it will reflect back from this point and it will go in such a way that it should meet focus, okay, in the backward direction. And the light which passes through this point, it will go, one second, not, let me just, yeah. So when, because it is what type of concave lens, right? So concave means it is diverging, right? So when light is going parallel to this, it will go back, it will not converge like in case of convex. All the light uh, con uh, converge to a single point, but here this is how it will go. And then if you see this light, which passes through this point, it reflect back in the same direction. So that's why we put this is incident ray and this is reflected ray. It reflect back. Now what we have to do, let's just, let me remove this arrow so you don't confuse. I'll put it here. Now if we, because the image means where the both rays are meeting, so if I converge it back to this point where these two rays are meeting, at this point I think I should use, if I do it like this, at this point it is meeting, right?
Yeah.
So this is the image, this, use a different color, this is the image. Draw an arrow to represent image. So make sure you draw arrow here. So it is image is smaller than the object.
Got it. The visitor moves further away from the security lens in the door. How does the size of the image change?
Yeah, if it goes back, the size of image will become smaller and smaller. So it will decrease.
Which material should the bolt be made out of? Iron. Iron.
Bold. Where is bold? This way should be. Yeah, it is iron. It is
It's
iron.
shown by the door when the switch is closed. It's shown by the door unlocks when the switch is closed.
Hmm.
When the switch is closed, current flows
Yeah, current
through
flows.
solenoid,
Yes.
causing magnetic field or something.
Yes, which create a magnetic field. Current creates a magnetic field around the solenoid,
Field around solenoid,
which make iron core
pulling,
into electromagnet.
which makes iron bolt an electromagnet,
Yeah, and
and
magnetic
the
field exert an attractive force on iron bolt.
attracts iron bolt backwards.
Yeah.
Okay. When the door unlocks, a force of 2.88 newtons is applied to the spring. Spring extends by 1.5 centimeters. Calculate spring constant.
Mm.
They give extension and they go for
Yeah. Force and extension is given. We have to find constant.
spring constant. Elastic potential energy equals 0.5 times spring constant times extension.
No, there is no
But
energy.
that's not limited. Spring constant, spring constant. Mm, not this one, not this one. Um, Force equals spring constant times extension.
Yes, exactly. Force equals this constant times extension.
Spring constant equals force divided by extension.
Yes,
So 2.8 Newton divided by, and then you
2.88.
do 1.5 centimeters to meters. So
Yeah,
1.5 divided by 100
yes. 1.5 divided by 100.
equals 0.015 meters. So 0.015, 2.88 divided by 0.015. Let's see. 192.
Yes, 192, right?
Yeah. You have two ways the resultant force on the bolt could be increased. Increasing current. Um,
Yeah, increase the current in the solenoid and increase the
turns in the
exactly turns in the coil, number of turns.
mhm. Figure 7 shows two ice hockey players moving towards each other. They collide and then they move off together. During the
Hmm.
collision, the total momentum of the players is conserved. What is meant by the momentum is conserved? The momentum is kept the same and none is lost.
Yeah, the total momentum before collision is equal to total momentum after collision. This is what it means, okay?
Immediately after the collision, the two players move together to the right. Calculate the velocity of the two players immediately after the collision. Okay. So velocity equals final velocity minus initial velocity equals acceleration times distance. No, you don't use this one.
Uh,
Do I use that one?
no, this is related to momentum.
So I need the velocity. I have the mass and the initial velocities. So mass and initial velocity. I need velocity. One sec. Um, velocity.
Use the conservation of momentum formula.
Conservation momentum. Where's that one?
It's not there.
Momentum equals mass times velocity.
Yeah, momentum equals mass times velocity. So according to conservation of momentum before collision and after collision is equal. So we will write total momentum before collision is equals to total momentum after collision. So let's say we name before collision as um, PA plus PB. After collision, it combines and it make A plus B. Okay, so mass
Yeah.
times velocity. Mass is I think 78 kilograms for A for the first one, and for that velocity is 7.5, right? And mass,
So one sec. Momentum for A is 78 times 7.5.
yeah, 7.5
Is it times 7.5?
times 7.5, 7.5 times
Okay.
78, because mass times velocity, this is the formula. Now add for the second one. What is the mass for second is 91 kilograms times velocity.
Momentum for B 91 times minus 5.5.
Yes, and after collision it's 169, right? Is it? Check it.
Yeah.
Yes, and
91 times
V. Let's say we
bracket.
name it as V because we have to calculate it, right?
Yeah.
Now let's solve this side. 7.5 times
91, not 91 times minus 5.5 is minus 500.5.
yes, minus 500.5, and this one is 500. Yeah, so there is a minus sign between them. Okay, is equals to 169V, right?
And then this equals 585. So 585 minus 500.5 equals 169 velocity.
Yeah, subtract these two.
One sec. So 84.5.
Yes. Now to find V, we have to.
84.5
Hmm.
equals 169 V.
Yeah.
So then V equals 169 divided by 169.
Yes, divide by
84
169, which is
is 0.5.
0.5 meters per second. That's correct. So remember this formula, okay,
Yeah.
for conservation of momentum.
Okay. The ice hockey player wear protective pads filled with foam. Explain how the protective pads help to reduce injury when the players collide. When players collide, the pads help absorb the impact delivered to both when colliding, meaning less force is put on the players.
And less force means it decrease rate of change of momentum, right?
Yeah. Figure 8 shows a student playing with a remote control car. Remote control transmits radio waves to the car aerial. Transmitted radio waves at a frequency of 320. Speed of radio waves equals 3 times 10 to the 8 meters per second. Calculate the wavelength of the radio waves. So they give you waves, frequency, and
Hmm.
wave. So wave speed equals frequency times wavelength.
Yes, speed equals frequency times wavelength.
And wavelength is equal to wave speed divided by wave frequency.
Yes.
Which so you do speed is 3 times 10 to the power of 8,
Yeah.
and then frequency you change, so 320 megahertz
Mega means
to
you will add
hertz
10 to the power 6, which is 6 zeros. 10 to the power 6 hertz. 1 megahertz is equals to 10 to the power 6 hertz.
is the million.
Yeah, that's million. 6 zeros.
So 320 times 1 million, 320 million hertz. So then 320, so 3 times 3 times 10 to the power of 8
Hmm.
divided by 320 million equals 0.9375.
Yeah, that's correct. Good.
So 0.93
Yes.
wavelength is 0.93
And
unit
it's
hertz
meters. No, that's for
meters.
frequency. Hertz is for frequency.
So is meters.
Yeah.
Wavelength is meters.
Yes, for wavelength, the unit is meter because that's just distance.
Okay. The car aerial is connected to an electrical circuit in the car. Describe what happens in the electrical circuit when the car aerial absorbs radio waves. Uh,
So what happens?
don't know.
Electrons oscillate and at the same frequency as the radio wave. So electrons oscillate at the same frequency.
Same frequency as radio waves.
Hmm.
Same frequency of radio waves.
Yeah.
Is that produces sound waves? We have two ways in which radio waves are different to sound waves. Radio waves are slower.
Radio waves are slower than sound.
Yeah, I think so.
I think radio waves are faster because they are electromagnetic rays, right? Than sound waves. So
Radio waves faster
than sound
than
waves.
sound waves.
Also, radio waves are transverse and transverse wave, and sound waves are longitudinal.
Radio is transverse.
So any electromagnetic wave is
Sound
transverse.
longitudinal. Figure 9 shows a distance time graph for the first 30 seconds of car motion. Describe the motion of the car during the first 30 seconds. Accelerating.
Yes, it is accelerating. Good.
Determine the speed of the car 20 seconds after it started to move. So 20 seconds, and then you cross over is the 2.8
Determine the
meters.
20 seconds after it started to move. After 20, it started to move. So again,
Speed of the car 2.8 meters. So 2.8 meters in 20 seconds. So 1 second, so you divide by 20. So 2.8 divided by 20 equals 0.14 meters in
no.
1 second.
See, what you have to determine speed of car 20 seconds after it started to move. So you have to use again the same concept. If you draw a tangent here, you have to find gradient actually. So let's draw a tangent here. Tangent means passing through this, or you can take any 2 points. Suppose I'm taking this 25 one point, and 1 point I'm taking 15, because this line will pass through this. So I need 2 points on graph. Now at 25, what is the value of distance? We will subtract these 2 points. So I think that's 4.2 minus this one.
4.4.
Is that 4.4? Okay. So let's take 4.4 minus, At 15, what is the value? It's
Um,
1.8, I think. We divide it by 25 and 15, subtract it, so you will get 10. And here if we subtract this 4.4 and 1.8, which is equals to 2.6, if we divide 2.6 by 10, we will get 0.26 meters per second. That is the answer. Okay. Whenever
yeah.
you have to find speed on the graph and distance time graph is given, you have to use gradient formula. Take any 2 point, subtract y values, divide it by the corresponding x values. Okay, so let me see how many questions are remaining. Let's do 6.6, or what is the time right now? Okay, I think we can start in next class. Okay.